There's one final 2D shape that we need to know quite a bit about, and it's one that we've not really mentioned too much, and that is the circle. Now, we talked about how there is debate over a circle as to whether a circle is a single continuous line that starts and ends at the same point, or whether a circle is an infinitely many-sided polygon that has infinitely small sides, so small that we can't perceive them as separate sides, and we just see them as one continuous loop. Now, whichever one of those a circle happens to be, it is regardless a two-dimensional shape because it is flat. Therefore, it has to be included in our list of two-dimensional shapes. Now, we can't talk about circles using the same two-dimensional properties that we talked about the other shapes with, things like the angles and the sides. In fact, the only angle property we really know about circles is that the angles inside the circle come to 360 degrees, a full turn. In terms of things like symmetry, rotational symmetry, angle properties, side properties, there's not much to go on. So we have to look at circles in a slightly different way. And the first thing we need to know about circles are some terms to do with them. Certain words and parts of the circle that they describe. And we're going to have a look at these and what they mean. So the first word we need to be aware of, well, the first part of the circle that we're going to pick out is this one here. This dot right in the middle. Now, this point is right in the center of the circle. It is equally far away from any other point on the outside. It is in the center of the circle. And in fact, that is what it is called. It is said to be the center of the circle. Now, what I could do now is I could draw a line, and I could draw a line from one side of the circle to the other side of the circle that passes through the center, like that. And this line that I've just drawn that runs from one side of the circle to the other side through the center in any direction. This happens to be one particular one that I've drawn, but I could have drawn this going through in any direction. If we have a line like this that runs from one side of the circle to the other side of the circle, passing through the center, it is important that it passes through the center for this. That line is said to be a diameter. And a diameter of a circle is exactly that, a line that passes from one side of the circle to the other through the center. Now, the next part of the circle I could talk about is this one. So this is similar to our diameter, except this time we have a line that runs from the center of the circle to the outside edge, or of course in the other direction. So the diameter runs from one side to the other through the center, whereas this one here just runs from the outside to the middle. And this line is called a radius. And there is a connection between diameter and radius of the circle, and we will talk about that in a moment. One more basic part of the circle that we need to think about, and we need to think about the outside edge. Now, that outside edge has a distance. We could pick a point to start walking, we could walk around the outside of that circle, and we could finish up back where we started. It has a distance, therefore we can measure its distance. Now, the distance around the outside of any two-dimensional shape is called the perimeter, so we might expect that that would be the perimeter of a circle, except circles are not that nice, because of course they're not. This is maths. It's obviously not going to be called the perimeter. The distance around the outside edge of a circle is called instead the circumference. It is effectively the same as the perimeter. It's the distance around the outside. It's just that with circles, it gets a different name. Now, the circum part of the name, circum means around. So you could, for example, circumnavigate the globe, which means you would travel around the world. You could circumlocute on a topic, which is a fancy way of saying you talk around a topic without saying very much. There are probably other words you can think of as well. So the diameter, remember, is a line that runs from one side of the circle to the other through the center, whereas the radius just runs from one side of the circle to the center. There is therefore a connection between the diameter and the radius. A diameter is nothing more than two radius lines joined together, one running from the outside edge to the center, and then continuing on from the center to the other outside edge. Therefore, two radiuses go together to make a diameter, and there is a connection between them. And we can phrase that connection in two different ways. We could either say that the radius is half of the diameter, because it only runs half as far. It doesn't run all the way across the circle, it just runs to the middle. Or we could say that the diameter is twice the radius, 2 times the radius, which means if we know the length of one, we can find the length of the other. And that's going to be important because there are certain other properties of circles that we can look at that use diameters or radiuses, and it's important to be working with the correct one. But we're not always going to be given the one that we need, we might have to find it. So if we're given the radius, we could always double it to find the diameter. And if we're given the diameter, we could always halve it to find the radius, because there is this neat connection between the two. And there is the first of our important circle properties. There are a couple more terms that we need to know about circles. The ones we've just seen are probably the most important ones, and they are the ones that are going to help us do other things with circles. But there are a couple of other words that we need to be aware of, some of which we're going to come back to later, and some of which we're going to mention now and not really see again, but it's still important to be aware of them. So we consider our circle again, with the centre marked. Now what I'm going to do first is I'm going to draw in 2 different radiuses. I could have put those radiuses anywhere, but I happen to have put them here. But they are 2 radius lines. Now the bit that's between the 2 radius lines that I've just coloured in green, that green bit is said to be a sector of the circle. And a sector is just a chunk of the circle, a slice of the circle, if you like, made from cutting 2 radius lines anywhere on the circle. The white bit of the circle is also a sector. It's just a sector that's much bigger. But we cut 2 radius lines into the circle. The bit that we've cut out with that is a sector. I could also draw a line on the circle like this. So whereas the diameter of the circle is a line that runs from one side to the other through the centre, this particular line runs from one side to the other, but not through the centre. And any line that looks like this, anywhere on the circle, is said to be a chord. And the chord has cut the circle into 2 bits. This blue bit, for example, and the rest of the circle. And either of these, we're going to focus on the blue bit, but the bit that that chord is cutting off is said to be a segment, because it's kind of like the shape of a segment of orange. Final line that we can draw on this circle is a line like this. Now this could be anywhere on the circle, but the point is that it's outside the circle. And this is a single straight line that just touches the circle at one single point on its circumference. So it is a straight line that runs next to the circle, and just at one single point on the circumference, the line touches the edge of the circle. And that line is called a tangent. These are the terms that we need to know. Segment, chord, and tangent we're probably not really going to mention again too much. But sector we are going to come back to later on. These terms, however, much less widely used than the radius, diameter, and circumference ones from before. But it is still important to recognise these terms. Nice simple 1-mark question in the exam. Label a particular part of the circle. Either here is a bit that's been shaded in, write down the name of it, or draw one of these things on a circle. And you have to recognise what the word means, or recognise what the diagram is showing you to be able to write down the correct term.
Consider this particular circle with its diameter marked. Now what I'm going to do is I am going to find a piece of string. And I'm going to make sure that this piece of string is the same length as the diameter. And what I'm now going to do with that piece of string that is the same length as the diameter of this particular circle is I'm going to see how many times that piece of string will fit around the outside edge of the circle, i.e. the circumference, which remember, of course, is a fancy name for the perimeter, the distance around the outside. So I'm going to start with my string here where this particular diameter is marked, and I'm going to fit that as best I can around the outside, and then it gets to this point here. From there I'm going to swing it round, so that's 1 already, and then it will swing round to here, making 2, and then swing round to here, fit around this bottom edge like so, and then a little bit more there, so that's 3, 1, 2, 3, and, well, a little bit. 3 and a little bit times round the outside edge of that circle. I'm now going to find a slightly larger circle, and with another piece of string that is the length of the diameter of this circle, I'm going to see how many times that now larger piece of string will fit round the outside circumference of this larger circle. So let's do the same thing again, and that's 1, and then that will be 2, and then 3. Oh, and then a little bit. 3 and a little bit for this slightly larger circle. And what I'm now going to do is I'm going to find an even larger circle with an even larger diameter and an even larger piece of string. And I'm going to do exactly the same thing again and see how many times this piece of string will fit round the outside of this circle. So there's 1, 2, 3, and a little bit. So that's 3 different circles, and 3 times we've found the same fact. That the piece of string that is the same length as the diameter of any given circle will fit round the outside of that circle 3 and a little bit times. In fact, we can start to turn this into a fact, because it turns out that the same will be true for any circle we could possibly draw. That if we take a circle, mark its diameter, that diameter would fit around the outside edge, around the circumference, 3 and a bit times for any circle. Remember, as a circle it gets bigger, so will its diameter. So that diameter will fit around the outside edge of the circle exactly 3 and a bit times. Therefore, we could say that the circumference, which of course is the fancy name for the outside edge of the circle, must be, well, 3 and a bit times as big as the diameter. If the diameter will fit 3 and a bit times round the outside, then the circumference must be 3 and a bit times bigger than the diameter, and we can say that the circumference is 3 and a bit times the diameter. Now actually, it would be better if we could work out what the and a bit was, rather than just say 3 and a bit, which is not very proper. And I can tell you that people did this, and people did exactly that experiment that we did, but did it much more carefully. And they found that the exact number of times that the diameter fits around the outside edge of the circumference is 3.14159265359, and actually that number goes on forever. But the diameter of a circle will fit round the circumference of that same circle 3.14159265359, and so on and so on and so on forever times. Which means that if we wanted to find the circumference, we could measure or calculate the diameter and then times it by this 3.14159265359 and so on and so forth, and that would give us the circumference. Problem is, that as a number is a little bit unwieldy. It goes on forever. And to try and write that down every time well, we'd have to remember at least a few digits. So what we do, because it's an important enough number, and circles are quite important, we give this number a particular name, like a code. Now we could call it anything. We could call it chair, or monkey, or sausage, but they were already the names of other things. So the people who came up with this stuff, they had to use something else. So what they did is they turned to their alphabet, and they picked a letter from their alphabet. Now it turns out that it was the Greeks who were looking at this in particular, and they went to their alphabet and they picked one of their letters, and the letter they picked was the letter pi, like the food, but not spelt the same, obviously. And the letter pi, much like in our alphabet, had a symbol, and the symbol they used was the symbol pi, which is the symbol from the Greek alphabet for that letter. Why did they pick that letter? They just did. Honestly, there is no real reason for it. They looked at their alphabet, they picked a letter. It will be a little bit like us using X to code for something, like we saw with the angles questions, for example. Unknown angles, used the letter X as code for this angle is not known, work it out. In the same way that we might label corners of a shape A, B, C and D. They looked at this particular number and said, well, rather than write that down every time, we're simply going to write a letter. We're going to write down this symbol pi, and every time we write that down, we are going to mean this number 3.14159265359, which is nothing more than the number of times the diameter fits around the outside edge of the circle, fits around the circumference. And that gives rise to the second of our circle properties that we can look at.
And as we've just seen, we can add another fact to our list. And the fact that we can add to our list is that the circumference of a circle is pi times the diameter. If we have the length of the diameter given to us, we can times it by this number pi, this 3.141592 and so on and so forth, and that will give us the circumference of the circle.
Work out the circumference of the circle correct to 2 decimal places. So, in this question, we are asked to work out the circumference. First thing we're going to do is we're going to start off with the formula. Circumference is this number, pi times the diameter. We're always going to write that down because eventually we're going to have another formula that we need to be aware of, another rule that we need to be aware of, so we're going to write down the correct one. Pi, this number, 3.1415 and so on, times the diameter. We then look at the diagram. Are we given the diameter? The line that is there runs from one side of the circle to the other through the centre and is 10 centimetres long. Because it runs from one side of the circle to the other, it is a diameter, which means we can use the 10. Therefore, our circumference is pi times 10. Now, the first thing we're going to do is we're going to write this answer not as an actual number, but where this question says, correct 2 decimal places, the question could alternatively say, giving your answer in terms of pi. Which means that our answer should be a certain number of pi. Well, if we've got pi times 10, we could alternatively switch that over. Remember, we can do times questions in any order, and we could say that that is 10 lots of pi. Which means we could write that as 10 lots of pi or 10 pi. We drop out the times sign just for convenience. 10 lots of pi or 10 pi. And that is what we're going to do if the question says giving your answer in terms of pi. In fact, I'm going to suggest we do it for every question just in case, because you never know. Now, what we actually want is we want our answer given in terms of a decimal, because the question asks us to do to 2 decimal places. So what we do is we grab our calculators. And we look on the calculator for the pi button, which unfortunately is quite well hidden. It is, in fact, here, above your times 10 to the x or exp standard form button. It is here on mine in yellow, which means I need to press the shift button, shift, and then times 10 to the x, and that will bring up pi on screen. If I press equals now, well, it simply returns the answer pi, because my calculator is once again seeing that as the neatest thing that we could do, the neatest way to write that answer. So it might be that on some calculators we have to press that S to D button, remember, to turn it into a decimal. And if I do that, then I return the answer 3.14159 and so on. Because that's what we're expecting to see if we were to turn this number pi into a decimal. Now we didn't want pi here, we wanted 10 lots of pi, or pi times 10. So I could go shift and then times 10 to the x to get my pi, and then times 10, press equals, and again it returns 10 pi. That to give our answer in terms of pi, like we said before. And I could press the S to D to turn that into something a bit more useful. What I'm going to do with my answer is I'm going to write down a bit more than I need first of all, and then I'm going to worry about the rounding. So I'm going to go for 31.4159 ... and then I'm going to round it how I need to. We need to give it to 2 decimal places we were asked for in the question. This is fairly typical of Circle's questions. So we count 1, 2 things after the decimal point, and there is our split line. It's either going to stay as 31.41 or it's going to change to 31.42, where the thing just before that line is the only thing that's going to stay or change. The 5 after the line means that the 1 is going to push up, in fact, to the 31.42 because it's going to be closer to that upper value by definition. So 31.42 centimetres, because it's a distance around the outside, so it's going to have the same units as the diameter. Work out the circumference of the circle, correct to 2 decimal places. So we're asked to work out the circumference again. So once again, we're going to start with the formula. Circumference equals pi times diameter, where pi is just code for this number 3.14159 and so on. We look at the question and we say, is the measure that's given to us the diameter? And actually in this case, no, it isn't. We are instead given a radius. We cannot use the radius in this formula. We have to use the diameter, which means we are going to have to use that radius to find the diameter. Now, if the radius is 4 centimetres, the diameter, well, we have that link between radius and diameter. The diameter is simply twice the radius, so it'll be 2 lots of the 4 is 8 centimetres for the diameter. Therefore, our circumference will be pi times the 8 centimetres for the diameter. First thing we're going to do, we're going to write it in terms of pi, so 8 pi. Second thing we're going to do, we're going to grab our calculators, we're going to do pi times 8. We're going to use the shift and then the times 10 to the x or the exp button to get our pi, times that by 8, press the equals, and if we need to, we're going to press the S to D because the 8 pi we've already got. We're more interested in the decimal answer, 25.13274,123. So 25.1327 ... and then I'm going to round that to 2 decimal places. There's my split line, so it will be 25.13. It'll stay as a 3 because the number after the line is a 2, which is going to keep it at the lower one. So 25.13 centimetres once again. Now, as a circle is a 2-dimensional shape, it makes sense that we would be doing similar kinds of things with circles as we did with the other 2-dimensional shapes. Now, we've already looked at a circle's properties, much like we did with the other 2D shapes. We've also looked at finding the, well, perimeter, effectively. It's called circumference here, but it's still kind of finding the distance around the outside, or the perimeter. The other thing we did with 2D shapes is we learned how to find their areas for certain shapes. We also need to be able to find the area of a circle. That's the amount of space inside a circle. Now, there is a formula for this, much like there is a formula for working out the circumference. And the formula does also involve this number pi, it turns out. There are various ways to prove why the formula for the area of a circle is what it is. There are various ways to prove why an area of a circle is calculated in this way. The problem is most of them are quite long and a little bit complex. So what I'm going to suggest we do is we break with tradition, and I'm not necessarily going to show you where this comes from. I'm more going to tell you what the formula is, and then we're just going to work with it. It's not something I particularly like doing. I would rather show you where it came from. But as I say, quite long, quite complicated, for very little gain. So what I would suggest you do, if you are interested in seeing where the area of a circle formula comes from, do feel free to look it up. If you're happy to just work with the formula, then please feel free to also do that.
And so we can complete our set of circle properties, circle facts, with the fact that the area of a circle is that number pi, again 3.141592, and so on and so forth. This number that we're giving the name pi to, we times that by the radius, and then we times it by the radius again. Notice that this is not 2 times the radius, this is the radius times the radius. They are not the same thing.
Work out the area of the circle, giving your answer correct to 2 decimal places. So once again, we're going to start with the formula which we've just seen. We've just seen that the area of a circle is worked out by doing pi times the radius times the radius. And we look at the diagram and we ask, are we given a radius? Well, that 4 centimetre line runs from the centre to the outside edge, so yes we are. Therefore, our area is pi times 4 times 4, which notice is not the same as 2 lots of 4, it is 4 times 4, 4 times itself. Now the first thing we're going to do is we're going to write this in terms of pi, much like we did with the circumference stuff before. The number part here is 4 times 4, which is 16, therefore we have overall got 16 lots of pi, or 16 pi. Alternatively, we might want to do it as a number like this question wants us to do, and so we grab our calculators once again. And once again, we use the shift times 10 to the x thing to get the pi up. We're going to times it by 4, we're going to times it by 4 again, and press equals. My calculator returns 16 pi, like we've just talked about, and I'm going to press the S to D to turn it into a decimal, 50.2654, and then some other stuff. So we have worked out that the area of this circle is 50.265. 4 ... and if we round that to 2 decimal places, 0.27 is the 5. After that line, we'll push that 6 up into being a 27. We need a set of units for this. Now, it's worth pointing out that with area calculations, we were doing 2 different dimensions multiplied together. We were often timesing a direction in one way and a direction in another, 2 different measures that we were using. Well, we are kind of doing that here, a radius and a radius. That's 2 different measures that we are timesing together. Okay, they happen to be the same one, but it's still 2 different measures. It's an area, so the units should match what we expect for area, and area calculations always yielded answers with the units of units squared. Centimetre squared, metre squared, that kind of thing. The same is going to be true here because it's still an area. So our answer is going to be in centimetres squared. Work out the area of the circle, giving your answer correct to 2 decimal places. As always, we start with the formula. Area equals pi times the radius times the radius. And we ask, simple question, are we given the radius? Well, actually the answer to this is no, we are not. We are given the diameter, and we cannot use the diameter in these area questions because the formula wants us to use the radius. So we have to work out the size of the radius. Well, if the diameter is 12 centimetres long, then the radius must be half as much. It must be 12 divided by 2 is 6 centimetres in length. Therefore, our area is going to be calculated by doing pi times the 6 times the 6. 6 times 6 is 36, so 36 pi. Leave our answers in terms of pi, and then we grab our calculator to work out the decimal part of it. Shift times 10 to the x to get the pi on screen, times 6 times 6, press equals. 36 pi comes out, S to D if we need to convert it to a decimal answer. 113.09733355, 113.0973 ... or 2 decimal places split there. The 9 is either going to stay as a 9 or it's going to shift up into the next number. The 7 after that split line is going to push us up to the next one. So the 9 is going to have to push up to, well, it's going to have to push up to the 0.10. In fact, so 113.10. What units? We're working in centimetres. This is an area, so centimetres squared. Work out the area and perimeter of the semicircle, correct to 2 decimal places. Well, we're going to tackle these one at a time. We're going to tackle the area first of all, because it's probably the easier of the two to look at, weirdly. We don't know how to find the area of a semicircle, but we do know how to find the area of a circle. Now, the key thing about the semicircle is that it is exactly that. It is half of a full circle. So what I'm going to do is I'm going to draw in the rest of the circle. Like that. Yes, I know that doesn't look much like a circle. Thank you. What I can now do is I can now find the area of the circle, as in the full circle. That will be pi times the radius times the radius, which will be pi times, well, the 6 that I'm given is the diameter of the circle. It runs from one side to the other. So the radius must be half of that and must be 3. So pi times 3 is 9 pi. Or, if I do that on my calculator, I could put pi times 3 into my calculator, and I will come out with 28.2743 centimetres squared. Which is fair enough. That is the area of the circle. So how then can we use that to find the area of the semicircle? Which is what we are after. Well, if the semicircle is half of the circle, then half of the area must be contained in that semicircle. Therefore, all we need to do is take that area and divide it by 2. 28.2743 ... divided by 2 is 14.13715, or 14.14 centimetres squared if we round to 2 decimal places. And we have worked out the area of the semicircle. We could use the same full circle to help us work out the perimeter of the semicircle, because now that we've got a full circle, we could, for example, think about the circumference of the circle. The full circle, that is going to be pi times the diameter. Well, we're given the diameter, so it will be simply pi times 6, or 6 pi. And if we pop that into our calculators, pi times 6, press equals S to D if we need to, 18.8496 centimetres. Fine, but that wasn't what we were interested in. We only have half the circle for the semicircle. So this bit here, this curved bit around the top, is going to be half of the circumference. So this bit here is going to be 18.8496 divided by 2 is 9.4248 centimetres. But that is not the perimeter. Why is that not the perimeter of the semicircle? Yes, because we have forgotten to include this edge here. This is not part of the circumference of the circle, but it is part of the perimeter of the semicircle. Perimeter of the semicircle, we would go around the outside edge of the semicircle. So we'd have to have this 9.4248 centimetre bit here on this curve, but we'd also need the 6 centimetres across there for it to be the perimeter. So the perimeter would be the 9.4248 added to the 6, which will give us 15.4248, or 15.42 centimetres given to 2 decimal places. Now, as we mentioned earlier, this is a sector. So we take a circle, we look at 2 radius lines, and that slice that we've cut out is a sector. Now that sector is another shape of its own. It is a piece of a circle, but it has a name. It has the name sector. Now what we need to be able to work out is we need to be able to work out the area of a given sector, and we also need to be able to work out something called the arc length. Now the area of the sector is simply the amount of space inside. That's fair enough and probably not that surprising. But the arc length is a very particular thing. Now the arc length is the length of this curved bit here, because this is an arc. An arc is a piece of the circumference, the whole circle. It's the curved edge on a sector, basically. And the fact that the sector is a piece of the circle and that the arc is a piece of the whole circle's circumference, that tells us how we are going to work out arc length and the area of the sector. Let's have a look at an example. Work out the arc length and area of this sector. So what we have is we have a sector. The radius lines that make up the straight edges of this sector are 7 centimetres in length. And we also have a 30-degree angle marked there at the centre. Now that angle is obviously important, otherwise it wouldn't be there. We're going to come to the angles shortly. What we're going to do with this sector is we're going to play on the fact that the sector is a piece of the whole circle. And we are, similar to the semicircle question, going to draw in the rest of the circle. It only needs to be a sketch just to tip us off to what we're doing here. And what we can now do is we can now work out, first of all, the area and circumference of the whole circle. Well, let's do the circumference first. So step 1 can be circumference is going to be pi times the diameter. Well, if the 7 centimetres there is a radius, the diameter is going to be 14, so it will be pi times 14, or 14 pi, or 43.982 centimetres. We could also work out the area of the whole circle. And the area is pi times the radius, which will be pi times 7 times 7. 7 sevens are 49, so 49 pi, or 153.938 centimetres squared. But we don't have the whole circle. Now that sector is not obviously, say, half or a quarter of the whole circle, but it is clearly a chunk. So the question is, what size of chunk? Well, this is where the 30-degree angle comes into play. How many of these sectors would make up the whole circle? How many 30-degree sectors make up 360 degrees? So then we could count up in 30s. 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. There will be, step 2, 360 divided by 30 degrees is 12 sectors. 12 of these sectors would make up this circumference and this area. 12 of these arc lengths make up the 43.982, and 12 of these sectors, in terms of their area, make up the whole area of the circle. What could we now do then to find the area and arc length of just one of these? Well, we simply need to take these two things, the circumference of the whole circle and the area of the whole circle, and divide them by 12. We're splitting them up into 12 equal parts because 12 of these sectors go together to make the whole thing. So step 3 then, the arc length will be the circumference divided by 12. So that's 43.982 divided by 12 is 3.6651 ... or 3.67 centimetres to 2 decimal places. And the sector area will be the area of the circle divided by 12. So that will be the 153.938 divided by 12, which comes to 12.8281 ... or 12.83 centimetres squared to 2 decimal places.